You should see that. All right. Okay, so let's get started then. Welcome to our final OKSci meeting for 2020. We will be talking about driving questions boards today. Um, my name is Heather Johnston. I am the Director of Science and Engineering Education at the State Department. We do have a small science team, small but mighty, that works together. Susan Ray is our OKXL science specialist. Donna Schweitzer is also a science instructional specialist. She will be helping a lot with the framework rewrites. And Samantha Shepard, who has also joined us tonight, she is our science assessment specialist. So if you ever have questions concerning the state test for, yes, hey Sam, 5th, 8th, and 11th grade, you can contact her. She is great. She will be able to help you. So some Zoom things, just in case you don't know where they are located. We will be using the chat box tonight. Feel free to use that. You don't have to worry about renaming yourself or anything like that today. Some session norms. I would love to know who is here and where you are from. So please feel free to write that in the chat box, say hello. Include your grade level or your subject area. We do ask that you stay muted unless you have a question, just for background noise. You can turn your camera on if you would like. It's not required, so don't feel obligated in doing that. And then questions can also go in the chat box. As we are a small group, though, feel free to unmute and just openly ask your question as we move through the slides. Because today is about you and learning about the driving question boards. And so at any point that you have questions about what we are doing or what we are discussing, please feel free to ask them. So to learn about the driving questions board, we are going to experience a phenomenon around a driving question board so you can kind of see what it looks like in practice rather than just talking about it. We are going to be exploring how the science and engineering practices and the cross-cutting concepts support student sense making of the phenomenon. I'm really excited about this part because I think it's a great way to see how we can intentionally use these dimensions to support student sense making beyond just like doing science. And at the very end, we're going to talk about resources that will assist in all three of these areas. So things to help with learning more about the driving question boards or about the dimensions that we discuss during the session today. Before we get started, though, I want to give a brief overview of our science standards so you know about where the dimensions are that we are talking about. So all of our standards are set up the exact same way. As you can see with this third grade example, we have the grade level, we have the topic, and then we have the performance expectation, which is our standard. And then the clarification and assessment boundary, which are just provide more information about that performance expectation. What we are going to focus on are these bottom three boxes. So we will be looking at what students are doing with the use of science and engineering practices, what students are learning through the use of our disciplinary core ideas, and how students are thinking about these core ideas by using the cross-cutting concepts. These three boxes are referred to as the foundational boxes because that is what the foundation of our standard is based on. So if you take this performance expectation, you can actually break it up into these three boxes. And so that's how all of those blend. But we're going to look at the foundational boxes and how to integrate all three through the use of a driving questions board. So what is a driving questions board? You can also refer to them as DQBs. So if I accidentally slip into acronyms, that might be one. If I ever use an acronym that you're not quite sure what it means because, education has tons of them, please let me know and I will clarify that for you. So, driving questions boards help engage students with an anchoring phenomenon. So, last month in our OKSci virtual meeting, we talked a lot about phenomena. If you missed that meeting, I'll be sure to include the link a little later so that you can get that recording. But an anchoring phenomenon is one that is used throughout an entire unit. So multiple lessons refer back to the same phenomenon. So driving questions boards are really useful if you have a phenomenon that is used throughout all of learning about a bundle of standards. Driving questions boards do have 4 components, and we're going to dive into each of them together. And that consists of the questioning, the investigations, and what we figure out. So I do have this, oops, if I click forward, this image here, and we're going to reference this image throughout this session. So that it makes a little bit more sense as we move through rather than just as one big image. Sorry. I do want to share the slide deck with y'all. So in the chat box, I just dropped the slide deck. So any of the links that I'm going to be referencing can be accessed inside the slide deck. All the resources and things like that, along with I'm going to be putting them in the chat as well so that you can easily access those. So the first section of a driving questions board are the questioning piece, the big part, right? So we have questioning here, and we are going to use questions to encourage students to be curious about science again, bringing that curiosity and wonder back into the science classroom. And then we also know that questioning can become more sophisticated as students move through their learning experiences pre-K through 12th grade, right? They can become a lot more complex, poised to look at more like similarities and differences. That learning skill progresses just like any of the other skills students learn in school. So to encourage questioning, you typically present a phenomenon, and presenting a phenomenon can be done in a variety of ways. You can do it through videos, you can do it through simulations, through data. You can have a reading, you could do a lab or an experiment. As we are virtual, I am going to be doing it through the use of a few videos. If you joined us last month, you will recognize these videos. I felt like using them again because they are pretty interesting about spiders here with this orb weaver. So what I'm going to ask you to do is the first thing is as we watch each of these videos, think about what do you notice? What do you wonder? What kind of questions do you have? And it can be questions about absolutely anything. As you have those questions, feel free to put them in the chat box. Then we'll watch the videos again one more time, but with a little more direction than just questions in general. So we're going to start watching parts of these videos. There we go.
I hope this is recording. I hope this is recording.
So that is video 1.
Oh my gosh! Whoa! That's so cool.
Okay, and part 3.
Oh. Oh, it's putting her little teeth in it.
All right, so we just watched 3 parts of a video about a spider on her web, and watched what happens when a bug gets trapped on the web, which was a mealworm placed on there. So, what questions might you have about what you observed? If you put a student hat on, so thinking even as a student, what kind of questions do you think students might have while they watched this? You can unmute or put it in the chat box.
I think some of my students would probably say, how did the spider know that the worm was there? And how fast it could spin the web.
Those are great observations and wonderings that they might have, right? How did the spider know that that bug was there? And then even, how quickly they were able to wrap the bug up. Good questions. What other questions might students have about this interaction? Maybe they wondered, do all spiders eat bugs? Right? Is that how all spiders capture their food? I think that could be a question that they come up with. The next thing that you would do as students would be sharing, there are different questions they might have about the spider interaction. You could give them a little more direction as to what kind of questions we might want to focus on. So you can provide a statement, and the statement is the phenomenon here. Spiders have an important role in their ecosystem. So this is a phenomenon that we can observe and use science to explain why spiders have this important role in ecosystems. So we're going to watch the videos, just a couple, we'll just watch part 1 and part 2. Parts of it again. And then I want you to think about what kinds of questions might students ask about this phenomenon, about spiders' roles in their ecosystem. So we'll just watch them through one more time.
Oh my gosh. I hope this is recording. Oh my gosh! Woo! That's so cool.
All right. So what kind of questions might we have about spiders and their roles in the ecosystem? What questions might students have about this?
They might come up with how many insects they eat, does that have this lost my train of thought, have a importance in the ecosystem? Um, does anything eat them? Could be also another question they might come up with.
That is great, right? Does anything eat them? How many bugs do they eat? Those are great questions that students might come up with, right? About spiders' roles in their ecosystems. Um, One that I would even have, are spiders really important? I know you said it was, but are they really? Because I don't like spiders. Spiders actually terrify me. So I've had to learn, like, why are they important? Right? That could even be a question that students have. So the students do have a lot of questions, and giving them a place to start thinking out loud where it's just like, ask your questions. It could be anything about spiders, about the ecosystems. It could be like, where are spiders found in all ecosystems or only certain ones, right? Do all spiders spin webs to catch their food? Do all spiders cocoon their food? How do spiders eat? Right? There's a lot of questions that students can be bringing up about roles in their ecosystem. So, what you would do with these questions as students are generating them is you would want to start gathering their questions in one location. This can be done in a variety of ways. Student can put their questions on note cards, on sticky notes, ripped up pieces of paper. I've done that before because I didn't have any note cards in my classroom, right? Digitally, you can use Jamboard. You can use Google Slides because you can insert, text boxes and that kind of thing as a ways to create sticky notes in Google Slides. We're going to use Jamboard today. Let me get the link for you. Okay, and on Jamboard, we are going to write in a couple of questions. I'm going to write down some of the ones that we talked about. If you have others and you would like to add them, feel free to do that. And I'm going to continue to share my screen so we can see the sticky notes here, right? But what's really important about this part of the driving questions board is that all questions are accepted. There's no questions that are not appropriate for this. When we're talking about spiders, we're talking about the ecosystems. They might have other questions about other organisms in the ecosystem. That's okay. Let them put them on sticky notes and add them to the question board, because really we just want them thinking about this. If you've never used Jamboard before and wanted to put your own sticky note, over here on the left-hand side, this image with the little bent up corner, that's your sticky notes. Something pops up and it lets you type your question in. I really liked how many bugs do spiders eat? Right, that was one of our questions, and so we can put them on there. The other ones, does anything eat spiders? That was a good one. We talk about how do spiders know a bug is in their web? Talk about do all spiders make webs? I'm going to write one more, and then we can talk about if you want to add anything. And you know what? Depending on the grade level, they might not even know what an ecosystem is. So that could even be a question. In Jamboard, as you were adding questions here, they just kind of line up. You just click on them and you can actually move them around however you want. So these were some that we mentioned, and then I added a couple extras. we look at here, do you have any other questions that you might want to add to our initial questions about spiders and their role in an ecosystem? So really that's like step one in a driving question board. Um, Creating all of those questions, you're going to get a whole bunch. And so, what you're going to do with them once we have all questions generated on our driving questions board is we're going to start looking at are there any similarities in these questions? Um, you want students to write their questions down and then share out because some students might have the same idea, and that's a great learning experience to recognize that other people are thinking like them. And so they begin to warm up to the idea of, I'm not the only one thinking that. So I'm going to be more willing to share as we are learning. So even if students have the exact same question, let them put it on the board because at this point, we're going to be bundling those ideas around a big idea. So what questions are similar? And then what's the big idea that makes them similar? Questions you can ask students to think about while everyone else is sharing is, do you have similar questions? And then at the end, did we leave something out? So if we're looking at our driving question board, we can look at what might be similar in this collection of questions, right? And so we do have questions like, here's one about an ecosystem. Why are spiders important? Are all spiders found in ecosystems? What is an ecosystem? This one talks about the bugs, more about bugs, about spiders and bugs. Spiders eating bugs. This could be a separate one too. And then, do all spiders make webs? Right? This kind of question could be in several areas. You might have that. And then you just ask for consensus. Get students talking about what they think should be grouped together. And you can ask questions like, do you think this goes here? What else could go here? Or so someone had a question about bugs. Does anyone else have questions about bugs that we could put in the same area? You're just trying to get them to now think about collecting these ideas into bundles. I'm going to put this one about webs into spiders eating. My thinking here is that I know that spiders can use webs to catch their food. And so I'm just going to group it there for us. And this one just doesn't happen to have any friends right now, right? And that's totally okay if it's a standalone question. What you do next is after we've bundled, we want to come up with the big idea for each of these bundles. And the big idea I would say on this right grouping is ecosystems, right? We're thinking about ecosystems here. I'm going to change up the color just so that it looks different. And that's the other thing that I really like about the jam boards, because you can assign sticky notes different colors to kind of keep track of what it is. We can talk about I'm going to talk about ecosystems, maybe relationships between organisms for this one. Do spiders eat anything? That could be more about being predators or spiders eaten, like a predator-prey relationship. And that almost could be a part of this other group too. You could come up with other big ideas here. Really, it's just representative of what students' questions are as they go through here. Now, sometimes teachers are concerned about what if students don't ask the questions that I need them to ask. I've never been in a situation where we were so far off that there weren't a few questions in the direction that I had hoped students would travel. And so as a teacher, you could always facilitate the thinking, and like nudge them into like, what other questions about that? Would you ever think of that? I wondered about this too. Or even as a teacher, you can model questioning. So if we're missing a big component and no one is bringing up that idea, you could go, you know what I wondered? And you could phrase a question around that missing component and then ask kids, what do you think about that? What do you wonder about whatever that missing component is? So then you can get their ideas contributed to it too. And then the students just think you're learning right along with them, which is a great um, modeling experience. And I'm going to be honest, I learned so much along with my students when we shifted to phenomenon, because I definitely did not know about all of the different phenomena I was using before I was using it. I knew a little bit, but I learned a lot more when I was working with my students. So this whole point in the beginning part of collecting the questions from students through an observation or learning experience around a phenomenon, bundling those questions, coming up with those big ideas, it's because we really want to develop a purpose for learning the science. So that especially when kids are like, why do I have to learn this? Why is this important? We have these questions that we all wanted to know about this phenomenon. And so we're learning the science to be able to answer our questions. So it really helps with that buy-in with students. This can also really help drive forward the lessons. If kids are wondering, like, what are we doing now? And we're like, okay, well, we answered this first set of bundled questions. What about this next set of bundled questions? And we're going to get into that sequence of learning here in just a moment. And then everything is tied back to that same learning experience so that we can all relate back to that spider that we watched on its web and the way it interacted with this mealworm that got onto its web. The cross-cutting concepts are my favorite dimension in our standards. Cross-cutting concepts are the thinking skills that students and engineers use. And whilst we want students to utilize the cross-cutting concepts while they're learning, it's also a really great tool for teachers to use to see how are students thinking about this phenomenon that I presented to them. They might not realize that they were using patterns or scale or system modeling, that kind of thinking, but I can recognize that in them and then foster that, right? So thinking about these cross-cutting concepts and thinking about the bundles here, I can think about, I wonder how are students approaching trying to understand this phenomenon? What kind of lens might students be using? And so I'm going to think about like ecosystems is definitely like a systems interaction. Um, and so like I can assign that here just as like a way of thinking on my end. How are students thinking about this? Another one could be about stability and change, right? What if spiders weren't in the ecosystem? Are they really that important, right? What if I removed all the spiders from an ecosystem? What would happen, right? That's even another question that could be added. That's kind of what we're thinking about here. So you can kind of see that it just gives us a lens and what are students, what tools are students using to approach this? And that's one of my favorite things about cross-cutting concepts is it helps provide that lens of thinking. So at this point, we finished questioning, right? We've got our student questions, we're bundling them, we put them into bundles around big ideas. What's next? We talked about this reference right at the beginning, this image here that I like to use with these DQBs. We've just went through this questioning piece around phenomenon. And now what we're going to think about are investigations. So now that we have questions, we need to do something next. And doing something next, right, with investigations, that means students should be doing something to learn these science ideas that will answer the questions that were developed at the beginning, right? So, how should we answer these questions, right? Well, the first thing we should look at is sequencing of the questions. We have this big board, we have multiple bundles, and we need to start somewhere. And you can get students engaged in this piece. This doesn't have to be just the science teacher planning all of it. You can be like, where do you think we should start? If we're learning about spiders and their ecosystems, should we start with the spider? Should we start with the ecosystem? And you can have those conversations with students and guide them, kind of what you would have normally done just independently, but getting their buy-in, thinking that they are thinking that they are making all of these decisions. They're probably going to be involved in multiple investigations. And we're going to get into what an investigation can be. It's not just a lab. Investigations can be so much more than having to set up for an experiment. Right. So if we were looking at planning out these investigations to address the questions that students came up with, we need to figure out where are we going to start, and then think about how might students investigate that bundle of questions. So while looking at our driving questions board, we had 2.5 bundles-ish right now, right? And you can think about, okay, should I first look at predator-prey relationships or ecosystems as a whole? For our discussion, I'm going to start on a smaller scale and just the relationship between the spider and the prey, and maybe what eats a spider, right? So is it a predator? Where is it as a predator? And we're, those kinds of terms that we're talking about with students. So I would think about, okay, maybe this will be number 1. I'm just going to write 1 here. So I would like to start here. And then obviously we only have 2 bundles here. So there could be a lot of components in between, but maybe not. Then we're going to look at the bigger picture of the spider and its role in all of this. So let's learn about the spider, and then let's learn about its role in the ecosystems. So then I'm thinking, how am I going to do that? Like, what kind of investigation should I be able to plan in order for students to engage with these ideas? Well, coming up with some of those ideas, it could be research. You could introduce another video or some observations. Maybe there's a spider or you have a tarantula and you just want to observe what's going on. There are simulations out there that you could be involved with, that you could utilize as part of your investigations. But whatever it is that you choose to do, we really want students carrying these out. We want them being active participants in that discovery of those science ideas. We want them to be able to use their own language, right, to describe these observations. And so we don't need to focus too much on accurate scientific vocabulary at this point. We want them grappling with the learning, with their learning using their own terms. And then as vocab presents itself, we can be like, oh, that's called a predator-prey relationship. You can start introducing the more sciencey stuff once they're trying to grapple with, like, how do I explain this? If I think this animal is going to eat this animal or bug or whatever it might be inside that ecosystem. Okay. Next, we've done questioning, we've done investigations. So students have come up with their own questions. They have carried out an investigation of some sort. They've gathered all of this information, all of these science ideas. Now what? Well, the next piece is, what did we just figure out? Yeah, right? We asked a question. We did something hands-on or researched. We got some, what did I figure out from that research? This is the big part of sense making, and where students are going to be connecting those things and pieces of information and data that they just gathered from their investigation and connecting it back to the phenomenon. So really, this is where classes spend most of their time, right, organizing all of that information that we just gathered. When I was in the classroom first learning how to do a lot of this, right, I'm pretty guilty of, we did the lab, we went over the answers of the lab, and then we moved on. And I, like, the lab was independent of anything. It didn't actually explain something. They had an experience, but I felt like I had to teach other things that they learned in this experience, but then I never connected the two. And what's really great about this driving question board, it structures it so that we can easily connect all of that information that we just gathered to the driving question board, which was all about answering about that phenomenon. So answering, why do spiders have an important role in their ecosystems? Organizing the information means we can start utilizing some of those science and engineering practices that are a part of our standards. 4 of them are highlighted here. We've already done asking questions. We already did planning and carrying out investigations. Here are 4 more, right? We've hit a bunch of science and engineering practices through this learning experience. So students, maybe they gathered data, and so now we need to analyze it. What patterns do they see? What does this data that they gathered tell us? Right? Maybe they need to develop a model. It's an ecosystem after all, right? They can develop a food chain if they're younger, a food web if they're older, right? Maybe we're starting to construct some explanations. Maybe students have some claims that they are thinking about spiders and their roles. Um, and maybe we need to communicate the information that we've gathered, or maybe we gathered some readings and we need to evaluate the information that was given to us. So there's several different ways that students can organize the info that they discovered through those investigations. We always want to connect back to those driving questions, right? So when we are discovering information, be like, how did that answer this question that we're trying to figure out? So connecting it back there. Um, Maybe students don't know how to grapple with the information that they just collected and we just organized. So we made a model, great. We put numbers into a data table, great. Now what, right? How am I supposed to look at these numbers and get anything out of it? Well, we could look for patterns. Do you see any patterns inside this data? Does any of the numbers look similar or different or repeating? Trying to focus their thinking inside of these. Or we drew an ecosystem. Great. Okay, what kind of relationships are what did the arrows mean between these ecosystems? What does that mean? Cause and effect. What if I removed the spider, right? Did that change the system any? Is that going to change the system any? What if it just was one spider? Does one spider affect the ecosystem? Or do a bunch of spiders have to be removed to affect the ecosystem, right? We can start using the cross-cutting concepts as a focus point to evaluate the information that they just gathered. Right, so some examples about that within the spider phenomenon itself, right? I could have asked students to develop models to show the relationships between organisms in the ecosystem. So maybe we watched some videos on spiders and ecosystems, and students were writing down information that they obtained from the video, and now we can organize that information into a food web. Right? Maybe I want them to start constructing an explanation about how spiders contribute to the stability of an ecosystem, right? These questions or these example tasks would be dependent on where we're at in the lesson, right? Some of them are going to be more complicated later on. I definitely wouldn't want to talk about stability of an ecosystem from the get-go if this was the first time we were talking about ecosystems, right? We got to start small, go big kind of thing. Yeah, so as students are sharing and being a part of this sense making, we really want to make sure students are doing the talking, not just the teacher, because the one doing the talking does the learning. As we're in these group discussions. So as students are making statements, always ask them, okay, what information did we gather from our investigation supports what you just said? Maybe as we're discussing and we're creating a classroom model, maybe they made a bunch of models on their own and now we're gathering information from their models and want to create a classroom model. Have students revise their work as we go through, right? Revisit what we did. What did we learn differently? Do we need to change any information? Well, let's fix that. so that students know that like it's okay to have a preconception that was incorrect, right? And so let's change that and revise our thinking so that it becomes more accurate as we progress through our learning about spiders and ecosystems. Through sense making, one of the things I want to highlight is don't immediately confirm that right answer. We don't want to be like, yes, that's correct, and then move on. You can ask students, does anyone agree with that? Do we have evidence that supports that statement? What else did we learn about it? Right? We want students to elaborate on their peers' idea to come to this agreement and understanding. All voices should be heard, right? You, as students are working, you can walk around the room and learn like student A can contribute at the beginning, but they don't have the advanced stuff, but they have the beginning stuff. So calling on them and be like, I want you to share out that idea because that was fabulous, and encouraging that participation piece. We can always group them all, not group them, but include them all in group discussions, right? Maybe students are struggling and don't know where to start. We can provide guiding questions to encourage that thinking and sentence starters. I'm going to provide some resources for sentence starters later on. But those are great things, right? Helping encourage students so that we disagree with thoughts and ideas, but not like you're wrong because, right? I disagree with that idea because, right? Or I agree with that idea because, so sentence starters are really great. When I talk about guiding questions, what I mean by guiding questions are really truly those questions that get students thinking about whatever the discussion is supposed to be on, right? So if I'm wanting to ask students about spiders and ecosystems, you can just straight out ask, what relationships were similar here? What relationships did you see? If they're older, we can talk about matter and energy, right? Why was the ecosystem and relationships important? It's about matter and energy transfer. What patterns did we see in the models that we drew, right? Why is it important for organisms to have specific roles in an ecosystem? Why does that even matter, right? So you can ask these questions to encourage students. You don't just have to all be quiet and wait and hope that someone speaks up. So that's the figuring out piece. So we asked questions, students got in there and did some science, trying to figure it out. We grappled with the information and they learned something. They learned that spiders play an important role because they eat a lot of bugs. And eating a lot of bugs is important because bugs would take over the world, right? If something wasn't helping control their numbers. Right, now what? Okay, that's the navigation piece. So if we looked at this big image, we've gone to using our practices. We did some figuring out. We answered maybe one of those set of bundles from our driving questions board, right? So if we reference this, maybe we answered this first section. We know that predator-prey relationship between spiders and its prey. Now looking at, okay, that we understand that. Now what do I need to do? And so this navigation piece is that now what? I've learned a couple of pieces of information that will come down here to build on my understanding of the phenomenon, but what is next? Right? This is that sequence of learning that we were discussing at the very beginning about placing those bundles in a particular order and connecting it back to the phenomenon. When we figured out one piece, we need to move on to the next piece, right? And this is very similar to what we already do in our classroom, but a lot of times we have these independent lessons that don't necessarily connect to the same ideas and require students to utilize the information learned in the previous step in the next step to better understand the anchoring phenomenon or an overarching science idea that is all connected back to standards, right? So we can revisit student questions. Maybe as they were investigating, new questions came up. And you can always add new questions to the board and be like, does it belong into a group that we have up here? Do we need to create a new group? What else do we need to figure out? So you can always revisit that question board after each one, be like, what did we figure out from this investigation? And then you can even X out, we learned this, and then let's move on to the next piece. So students can see that they are in fact learning stuff and progressing towards understanding this phenomenon that they experienced at the beginning. And that really is all the putting it all together, right? We get a piece and then we kind of start over. You get a piece, you start over. And that's why it's important to understand like these investigations, the doing part of science doesn't always have to be a full out experiment in the traditional sense of labs and beakers, right? You might have a experiment at the beginning or an investigation at the beginning, and then we need to go and do some research. Maybe I have some data that I can build around. Maybe I do some other readings or watch a video, do a simulation. All of these things count as investigations and involving students in their learning, and build on to better understanding of the phenomenon. Okay, that was a whole lot of information. Are there any questions before I move on to the resources? All right. So, wanting to learn more about driving questions board, I have the slide deck. I'll put that back in the chat box just in case you need it. It's linked with all of these resources inside that slide deck, right? So if you want to watch a couple minute video on what is a driving board question, feel free to do that. That's on here. Susan Ray presented a couple summers ago on a EngageOK on the road on driving questions board. So there is a presentation slide deck here, a blog post, and then NSTA, the National Science Teaching Association, has a collection of resources around driving questions boards. A couple are behind the membership paywall. However, most of them in this collection are free and you can access them on there. And NSTA has some new membership options that you can be it's like a free member and access so many resources each month for free on their website. You should check that out if you're not a member yet. If you want lessons that already involve the driving questions boards or units that involve the driving questions boards, or lessons that could be utilized in a driving questions board, these are 3 or 4 resources that follow this instructional strategy. And so those are all highlighted on here, OpenSci but that is middle school only. They are going to be expanding into high school this next year, but a complete high school curriculum is looking at like 3 years down the road for biology, chemistry, and physics. Next generation science storylines have a few units for elementary, middle, and high school. Inquiry Hub Biology is high school only, right? That's biology class. And then phenomenal GRC lessons. Those are just individual lessons, more traditional that we're probably used to versus full complete units. But they're still really great. Oklahoma teachers participated in a lot of the professional development around writing these GRC lessons. GRC stands for Gather, Reason, Communicate. And so it's really great. You can get on there and find lessons written by Oklahoma teachers. Crosscutting concepts. We're going to talk about that dimension first, as it is my favorite. I talked about prompts and sentence starters to help students with discussion. This link, this very first one, that's what these are, prompts for integrating cross-cutting concepts. It's even like set up as questions so that if you're wondering, how do I ask students about patterns beyond what patterns do you see? There's an entire page of ways to ask about patterns, and that's the same for all of the cross-cutting concepts. If you are wondering, how do I use cross-cutting concepts in different ways? So like I've got patterns, instead of looking for like repeating patterns, what other kind of patterns and how can I use patterns and better understanding some science ideas. These matrices are split up in K5, 6, 12 bundles, but they provide a range of ways cross-cutting concepts can be used. And then Appendix G just talks about the general background of like, what is a cross-cutting concept? Why are they important? And so if you're looking for more information about them, you can find that there. This section of resources on science and engineering practices look at about why they should be integrated into science learning and not taught independently. Like we're not thinking about the scientific method, or let's teach how to plan an investigation, but not around content, like doing it as a separate unit. Those are great readings to learn more about the importance of integrating it with their learning. And then this last bullet here, very similar to the cross-cutting concept prompts, those sentence starters. These are tasks for the science and engineering practices. So if you're wondering, how else do I get students to ask questions, to develop models, this resource provides ways that teachers present that science and engineering practice, and then how students interact with that task. So I really like those two, and trying to figure out other ways of engaging students in their learning. The last thing I want to highlight is that we will have a meeting next month. And we're going to talk about developing a coherent sequence of learning. We've discussed this idea last month in our phenomenon session, and then we've mentioned it a little bit about sequencing learning during this session as well. And so we're really going to focus in on that one topic at the end of January. If you want to attend, which of course I hope you do, you will register just like you did for this one. I'm putting that in the chat box, but it will also be in the science newsletter and in on the Facebook group. So you'll always have access to that and information about it as it gets closer. And that is the end of it. My contact information is right here. So if you ever have any questions as you are working through anything science related, you can feel free to email me those questions. But before we close out, are there any questions about driving questions boards? Well, okay. No questions, just answered them all, huh? Of course, you can email me if you do have them. Please do that. Otherwise, thank you so much for attending tonight. I appreciate that. I know it's been a crazy busy year. Go ahead and